everyone, and welcome to our presentation. Our topic that we were given was correlation design, and my group consists of Erin, Rebecca, and myself, Haley, and we really hope that you enjoy this. What is correlational design? Correlational design is a non-experimental research method that uses a statistical technique to discover if there is a relationship between two or more things. So for example, is there a correlation between having more cats and money spent? Correlation design is usually done without changing or manipulating any of the variables. Since there is no changing or manipulating of the variables, this means that correlation design can only show the connection between things and not what actually causes them. This is why often in correlation design research, you'll hear that correlation does not equal causation. Correlation comes from the Latin term cor and relational, meaning together relationship. So how variables move together over how one makes another happen. Words you might hear often used in correlational design are covary, which is a very fancy term used to describe how two or more things are connected. Is there a strong connection in the case of smoking and lung cancer? Or is there a weak connection like in the case of watching movies and pancreatic cancer, where one is predictable and the other is less likely? A pro to correlational design is that it helps clarify the relationship between variables that cannot be examined by other methods and allows prediction. A con to correlational design is that researchers cannot identify cause and effect. Correlational design. Correlational design is used to find the relationship between two variables. So for example, does having more cats mean you spend more money on cat supplies, and are they related somehow? Correlational design is also used when you want to test research to find out if the details are true. And lastly, it's used when you have basic knowledge of a subject or are seeing connection between two things. For the purpose of this slideshow, we will be using money and cats. We don't know that there is in fact a correlation between money spent and how many cats you own, or the correlation between a person's well-being and cats. But there seems to be an obvious connection. So we can test the theory and see if there is a correlation between them.
If each of the red dots on this graph represents a cat owner and the y-axis represents how much they spend on cat supplies and the x-axis represents how many cats they own, this graph is showing a strong positive correlation between owning multiple cats and spending more money. Even though the graph shows a connection between the number of pets and the amount of money spent, correlation does not equal causation. This means that even though the data on the graph shows that typically the more pets an individual owns, the more money they are spending, one does not cause the other, and there may be other contributing factors. There are two different types of correlational design. One is called explanatory. In explanatory correlational research, researchers want to know how one variable is related to the other. For example, how is the number of cats I own related to the amount of money I spend on pet supplies? There are some factors to help us identify a study as explanatory. They are a correlation between two or more variables, information from the participants is collected all at one time, all participants are analyzed as one group, each participant will have a score for each of the variables, the data analysis will include the correlation, and researchers will make a conclusion based on the results. The second type is called prediction design. In prediction design, researchers are trying to identify variables that will predict an outcome called the criterion variable. For example, if our criterion variable was the amount of money that cat owners are spending on supplies, then one of the predictor variables would be the number of cats that they own. The factors that help us identify a prediction design are that you will typically find the word prediction in the title. The variables are not all measured at the same time, and researchers can predict future outcomes based on their findings. One of the key characteristics of correlational research is the association between scores. The association includes the direction, form, and strength. In a positive correlation, when you have high scores on one variable, you will have high scores on the other variable, and when there are low scores in one, you will see low scores in the other. Using our previous example with number of cats and cost of supplies, picture 1 shows that when one increases, the other increases. And if there were a low score number of cats owned, there would also be a low score in the amount of money that is spent on cat supplies. In a negative correlation, shown in picture 2, When the y-axis increases, the x-axis decreases, and vice versa. This shows less money spent with a higher number of cats owned. Picture 3 illustrates an uncorrelated relationship. When there is no correlation, the score on the variable does not predict a score on the other variable. According to the findings recorded on this scatter plot, we could conclude that there is no relationship between the number of cats owned and the amount of money spent on supplies. Pictures 4 and 5 show what is called a curvilinear relationship. In picture 4, we see a decrease, plateau, and then an increase on the y-axis, or money spent, as the x-axis, or amount of cats, increases. Picture 5 shows the same distribution but opposite, an increase, plateau, and then decrease in money spent as the number of cats owned increases. The correlation coefficient ranges from -1 to 1. The closer it is to -1 or 1, the stronger the association between two variables. The closer it is to 0, the weaker the association. If we plotted the scores from our participants or pet owners, and it looked something like this, we can see that it is very steadily increasing with number of pets and number of dollars spent. So we can see that this is a positive correlation because as one axis is increasing, the other is increasing. If we were to draw a trend line, we see that every point is touching that line, and that is an indicator of a strong correlation. If our scores looked more like this, we can still see that for the most part, it is a positive direction. As one is increasing, the other is increasing. However, if we were to draw our trend line here, we see that almost none of the points are even close to the line. So we have some pretty clear outliers like these ones here. So basically, the farther the points are away from the trend line, the weaker the association. So while they are still correlated, as the one axis increases, the other one increases, the connection is very, very weak.
So the second key characteristic to correlational design is the display of scores. So this is done in one of two ways. It's either done with scatter plots or it's done with a matrices. So the scatter plots are used to determine the degree, the form, the direction, the type of association, and the existence of extreme scores. So in the case of money and cats, we see that the majority of people fall upon this axis here. This would be a positive correlation between money and the amount of cats you have. And then it also takes into consideration extreme scores. So this is kind of like a low score and this is a really high score. So in this situation, this person might represent the crazy cat lady who likes to spend a ton of money on her cats. She buys them sweaters and cat trees and treats and expensive cat food. And this guy down here is the guy who kind of feeds his cats table scraps and lets them outside. The other option is through the matrices, as I mentioned. Now, the key to this would be that it's a series of numbers. It's basically a table with a series of numbers representing all these little scatter dots, including the extremes. And there are numbers that represent each of these dots. The 0.2 to 0.35 is equal to a slight relationship. The 0.36 to 0.65 is a limited relationship. This 0.66 and the 0.8 to 0.85 is a good relationship, which is normally where things fall when it comes to scatter plots and matrices. That's kind of a good average correlated number. And a 0.86 and higher relates to a really good relationship or a very high relationship. And these things are very difficult to find because, as we mentioned, causation and correlation are not the same thing. So it's very difficult to find something specifically that causes the display score to be equal to 1. The last key characteristic of correlational design is multiple variable analysis. This is done through two ways: partial correlation and multiple regression. In partial correlation, we look at one mediating variable that might cause a differential in or a different result. So in the case of our cat people, we might look at their income to determine how much money they get to spend or the number of cats that they actually have. In that situation, we would see how income would determine these two factors. And that would make income our mediating variable. In the case of multiple regression, it's a combined relationship between all the factors or multiple factors that might cause people to have more cats or spend more money on their cats. So that might be income, or the amount of food we buy, or the type of food we buy, or whether we have to drive to the store to get our cat food, or whether we buy them sweaters. This is done on our linear score here, and it uses this regression line with this equation below, which is also on the slide if you would like a clearer image of it. Y is our prediction, so this is where we aspire that this line will sit on the graph. B is equal to the slope, so whether it's positive or negative. X is the actual score, so where these little numbers actually sit, and A is the constant, and that would be your number of cats or your money, whatever the case may be. Another way that researchers have looked at correlational design is through meta-analysis. So this is an extension of correlational design. And it's a format where you take similar studies and they're all analyzed and contrasted with their results. This is quite similar to what we've been doing regarding our studies thus far in CJ's class, in that there is a 6-step process to doing it. So we start out with problem formulation, where we determine if there are enough studies done on the amount of money spent versus the amount of cats we own. Then there's the search and gather, where we literally search through all the papers and the studies, and we gather all the information to determine what has and hasn't actually been studied. Then we do a criteria review, where the studies are then divided into certain characteristics of things that might be like variables, outcomes, or sample size, for example. And then we move into the effect size, which we take all the information we got in our criteria review and we kind of average it out. Then we go into our summary step, which is the calculation and accounting for the different forms of variation that have happened in our effect size. And then those things are kind of divided up into age, race, gender, those types of specific things. And then the researcher then interprets the meaning of the summary effect, and then determines what it all means. So in a situation where we consider our cats and money, we might have gone through all the research and found that the demographic of people who spend the most money on their cats is 70-year-old ladies. And in that situation, we would look into finding out why 70-year-old ladies are the highest demographic. Is it because they particularly love cats? Is it because they are very lonely people? Is it because their cats keep them company? There could be a thousand reasons, but again, the cause of these, or the results of these, may not necessarily be the cause of why somebody spends more on cats. They just might do that regardless. There are also some advanced correlational statistical procedures that we looked into, and they are in our textbook from pages 358 to 362 with more detail. And there's also some information in the MyLab online that will give you more information on these. So we're just going to kind of touch lightly on them. They include things like factor analysis, discriminant functional analysis, interclass correlation, path analysis, structural equation modeling, and hierarchical linear modeling. So factor analysis takes in a high and moderate correlations and factors them into smaller parts. So if we were to divide a group of 100 people, we would divide that group into, say, 70-year-old little old ladies, 20-something young single women, and 30-year-old bachelors that all have cats. To kind of give us a better understanding on how to divide those up so we can do some more of the regression analysis. The second part is discriminant functional analysis, which explains the categorical differences in independent variables. So in that situation, we consider that there might be more than one researcher doing the analysis. And say, for example, we ask a series of people about their well-being with cats. Rebecca might score that person on a 5, I could score them on a 3, and Haley would score them on a 2. So that part of the analysis is taken into consideration, that there are some discriminations or discrepancies that might occur in correlational research. Intraclass correlation is across the body study of just 2 classes. So it might be divided over race and gender, for example. Then we move on to path analysis, which looks at causal connections that might influence the outcome. So it might be that, little old ladies all have friends that also have cats, and so they've opted to get a cat. That might be a casual idea of why little old ladies in their 70s are the largest demographic of people owning cats. Then we move on to structural equation modeling, which is like an extension of path analysis. However, it's usually looked at a structured relationship between variables, so like a family of variables. And typically that kind of research is done through a lot of computer science type things, algorithms. There's a lot of equations that are involved in it. The last one is hierarchical linear modeling, and that's helped to compare the differences between levels of outcomes. What that basically means is that we would look at different hierarchical levels of people under a certain group. So in the case of cats and money, we might look at somebody who makes, $30,000 a year. We might look at somebody who makes $60,000 a year. We might look at how it affects people who only make $100,000 a year. So it divides those groups up into different subgroups. Next, we'll talk about the steps in conducting a correlational study. There are 6 different ones. The first one being that we determine if a correlation study is best addressed to research the problem. So in this circumstance, in order to use correlational study, you would need at least 2 things to compare to one another. So in our example, we are saying that the amount of cats you have determines how much money you spend. So those are 2 things that we felt would work in this circumstance. So we felt that correlational research would represent the best for that. The next thing you'd have to do is identify individuals to study. Now, it depends on what your particular demographic is. If you want to know what a 70-year-old little old lady spends on each cat based on her or what she spends on each cat, then that might be a different demographic to study versus the population as a whole. So all of Canada, what is the difference in their cat spending, basically. The third step is to identify 2 or more measures for each individual in the study. So in our situation, the 2 measures that we picked were the amount of cats that somebody had and the amount of money that they spent. However, these types of things could vary based upon your own research. It might be instead the amount of people with depressive disorders and abuse, or it might be the amount of gas used in a car for your travel to work. So those kinds of things would identify the measures. At that point, the fourth step would be to collect the data and monitor potential threats. So at this point, you would gather all the information from your group that you've pulled together. In our case, we'll say, we've looked at 70-year-old little old ladies, and we've collected their data, and we've monitored to ensure that it is as accurate as possible. And that we're getting proper numbers. So we might say ask for, an average receipt from somebody who has spent money buying cat food this week, from 70-year-old little old ladies who might be in the in the pet stores at that time. Then we analyze the data and represent the results. So at that point, what we would do is we would look at it all, we'd put it onto a scatter plot or throw it into a matrix and determine what exactly is the amount spent versus how many cats a person has owned, and then give it an average. And then we would interpret that result. So from there, we would look at the information and say that the average household spends $25 a month on one cat. And then, as that increases, perhaps two cats will cost the household $30, and that seems to be the average. Of course, we'll deal with extremes on both ends, as we previously mentioned. So those would be outsider cases. That's definitely something, if you wanted to, you could look into, but it would be difficult to use correlational research to identify that. And again, in this particular situation, we only analyze the information. We're not gathering information to get a confirmed cause, because there's so many causes to one potential correlation that there's no way to pinpoint one in particular.
Ethical issues in correlational research. The ethical issues surrounding correlational research are data collection, data analysis, and data reporting and presenting. First, we are going to take a look at data collection. When collecting data, the results can be skewed when not taking in consideration of all influencing factors. All possible influencing factors need to be considered to have a proper sample size. For example, if you're trying to measure how much a person spends on their cat in London, Ontario, and only ask 100 cat owners, the data will not truly reflect that cat owner population. Other factors that should be taken into consideration are number of cats owned, brand of cat supplies, as costs can vary, and income, as that can influence how much a person has to spend, and so on. Secondly, we'll take a look at data analysis. Researchers are cautioned about editing data or making data up. For example, researchers can breach ethics when stating that they have found cause and effect or probable cause, when the results show only patterns of relationships. Researchers need a thorough report of findings, including effect size and appropriate stats. The data cannot be made up. Further, an unusual amount of measurement error can cast doubt on the use of analysis procedure. An example of this would be the results from the sample size indicate that they have 10,000 cat owners in London, Ontario, but there is only actually 1,000. Another ethical issue in data analysis is the treatment of outliers. Outliers need to have a clear reason for being removed. The researcher should be transparent about it and the procedures with the outliers. Lastly, data reporting and presenting. There are many additional ethical issues that can present themselves in relation to correlational research, such as educational research should not be plagiarized, a failure to report contradictory findings, to publish the same findings multiple times and not share the results of the research with others. The ethics of good scholarship work suggests willingness to share data with others, publish their work in scholarly journals, and not let research reports sit unused in an office drawer, and including key philosophical assumptions about the research in the write-up. The write-up should include factual information about the relationships and not causation. Techniques for correlational research. The most suited sampling techniques are typical sampling, homogeneous sampling, and purposeful sampling. Least suited sampling techniques are critical sampling, extreme case sampling, and snowball sampling. To make our class presentation a little more interactive, we decided to include a class activity. Below you will find a link to Kahoot, which will bring you to a quiz of 10 questions relating to correlational design. The format will be multiple choice and true and false, and below there is also a game pin, which is 02842223. Thank you so much for watching our presentation. We hope you enjoyed.